Hello everyone, welcome to IGBits. We train and you learn. A warm welcome to you all. Uh, Today we are going to look at basic fundamental concepts of statistics. This is one of the baseline topic which we should actually go through before you attempt to do typical problems in you know higher end topics. So without further delay, let's get started. See how much we can cover. Based on the need, we will also see like more example problems as well. In solving them, I think you will build the concept in and around. If you have any question, then feel free to post it on in a chat window. We will we will answer. I wish I would like to let you know that we have a YouTube channel. The channel name IGBits. Feel free to log into YouTube and then subscribe the channel. Your support is very important and essential for us to sustain the channel information, keep updated, and then your helping hand will support us to build the more knowledge and then sharing across right all the people who are like us to actually get the access and then learn the unseen topics. Okay, and feel free to share the channel to the your circle so that we can extend our helping hand to the rest of the world. Thank you all for keep staying with us and then keep help expanding our channel data to rest of the world. Here is a high level uh, spectrum of like what are the topics that we are going to cover in statistics. See, fundamentally speaking, statistics are two types: theoretical statistics and then applied statistics. Theoretical in the sense like a mathematical statistics, whereas in applied statistics we have a descriptive statistics and then inference statistics. So descriptive means like we are organizing the data, we are summarizing the data, we are presenting the data in the meaningful form. That's called descriptive. Whereas inference, draw a conclusion, about a population-based data observation sample. Right. So mostly our concentration today would be descriptive, within which measure of central tendency. What are all subset of topics that we are going to cover in calculating the central tendency. For example, mean, mode, median, you know, would be covering in this uh, measure of central tendency. Whereas measure of dispersion, we have a range, mean deviation, standard deviation, and a quartile deviation. Inference is, this is like a higher standard topics which we are not going to cover, but under inference we have a like hypothesis, regressive analysis, and then many more topics. So I leave the option because we are mainly concentrating on a descriptive statistics in today's base class. So one important relationship that you might end up actually using them, if you know that like mean value, mode value, and then median value, the empirical relationship is what is given: 3 median equal to mode plus 2 mean. Mode means 3 times median minus 2 times mean. When the topic statistics comes into place, we have to understand two different things: what is mean by statistics and what are the applications of the statistics. Let me tell you the statistics applications. If you know the fundamental concept of statistics, what you will get it is understanding that how the school class students performing in the current curriculum, that you can get it from the statistics. The reason behind is that if you look at marks of the class and then if you can analyze them properly, you will be seeing that Okay, some kind of recognition, right? Some are scoring high, some are scoring average, some are maybe below average. So you are draw the conclusion out of that marks, awarded for the specific class, let's say, right? Then you can see like what decision that you have to take it to improve the below average people to bring to the above average maybe, right? So that's why if you think of, if you have the data, what you have to do is like first you will gather the data, you will review the data, you are properly analyzing the data, and then find out a, what you can call it as some sort of like a pattern recognition of the data, and then draw the conclusion, inference the data, and to make a appropriate decisions. That is how we have to think of in generally. Does it make sense? So I'm reiterating now. Statistics is the discipline that concern the collection of the data, organization of the data, analysis of the data, interpretation of the data, and then presentation of the data. So you have a, different graphs, can be leveraged to, you know represent the data in pictorial form, graphical form, so that graphics is basically gives like a lot of easy to understand rather than actually looking at the data, right? That's why a picture is like a worth of 100 words, isn't it, right? The same thing, statistics will also have like, uh, a numeric data as well as a graphical data, right? So the another part is like, when we talk about a statistics, what we are going to talk about is like we have two major areas that we have to concentrate: descriptive and then inferential. So because of the, syllabus limitation, what we can think of, descriptive is only the portion that we are going to cover. Inferential statistics probably you will be covering in, on higher classes, higher standards. Does it make sense? So now question is like data. When we say data, what is mean by, data, and how do I understand the data, right? So what I'm talking about here is, let's say I have the data. Data means the information in the form of numerical figures, right? So example, student marks 8, 55, 60, 75, 98, 65. These are all things probably you are saying is a data, isn't it? So not necessarily always like a numbers, right? You can also have a different data. Let's say data can be classified as a qualitative and then quantitative. Agree? So qualitative means what? Beauty, color, honest, etc. These kind of things we can say like a qualitative data. Quantitative data is like the numeric values like height, weight, distance. You have some kind of numbers, right? These are the abstract nouns. This is like, the value that you can assign to it. So that's why qualitative and quantitative are the two classifications of the data. We will deal with two different things also in your statistics. Mostly for your current curriculum, you will be more concentrated on a quantitative portion because you have a arithmetic mean, mode, median, things like that. You will be, you are going to actually solve the sums within which, right, that frame. Next one. So one fundamental primary thing that we have to understand is like data can also be classified as raw data and then grouping data. Raw data means what? Data obtained from direct observations. You are observing something like a marks, you are collecting the data. That is what you can call it as a raw data, right? But if you're taking the raw data and then let's say you are grouping, logically you are grouping them, right? On your convenient way, to extract something out of it, let's say. That is what we can call it as a grouped data. So condense the data into convenient number of classes or groups, that this helps in preserving the glance and certain silent features of the data. So you have to understand raw data and then group data are the two different data that you're going to deal with it. Okay. So the two more terms, observation and then frequency. What is mean by observation? Each each numerical data in a data is called an observation, right? Basically, these are the observations. Let's say 55, 60, 75, 98, 69. These are the observations that I made from the student marks. So this is called data. So you are observing and then you are quantifying. That's called observation. The frequency means the number of times that a particular observation occurs is called a frequency. Let's say if you have a data is something like that, uh, 2, 10, 15, 10, maybe 12 and 10. If you see, if you're trying to look at a 10 as a my data, number of times that particular observation. So my observation is on 10. Number of instances that my observation in my data, would be 3. If so, then the frequency is 3. That's how I'm saying. Frequency means number of times that particular observation occurs, right? Is called as a frequency. So observation and frequency is the two important terms that we have to remember, because we are most frequently gonna use in upcoming topics: observation, frequency, raw data, group data, qualitative, quantitative. You know, uh, I think these are precisely is important for now. Shall we move on to next topic? Quantitative data is classified into three types. We spoke about it. The data is a qualitative and quantitative. Now we are main focus is on quantitative. Quantitative is here further divided into three types: individual series, discrete series, and continuous series. We will see one by one in short way. So try to understand individual series means what. The definition: any raw data is collected and form an individual series. What that means is, let's say you are trying to actually collect the data from the student marks. What is your observations? Your observation is, say, like all the marks. So you got the marks is like something, 32, 40, let's say 55, 45, and 55, 70, 68, something that you are collecting, right? This is these are all observations you are collecting, and this is also called as a raw data, and then you are putting them in the series, and hence this is called individual series. So you've been dealing with this, but you are saying this is an individual series. Let's look at a discrete series in quantitative data. What is meant by discrete series? How it is different from individual series? Individual series is actually forming from the raw data, right? So discrete is also formulated from the raw data. So what this means, like here we are actually doing a one level up. So we are trying to measure the frequency of observations are taken into consideration. You got me what I'm saying? So let's say simple example. You are in a colony where we have 10 families. Okay, each family having like a computers. So some families have like more than one computer, some are like one computer, things like that. So let's say, for example, you are counting down all the computers from each family as a series. So let's say one, one, two, three, two, one, four, three, two, one, and one. So now what you are saying, like these are the computer count. Okay, this is a computer count. This is raw data for you. But what you are trying to say, these are all the data that you collected from the 10 families. Now you are reiterating back. So these are observations, right? These are the observations. But frequency of the observation is what is important for us. So what you are saying is like each family, how many computers may have, right? How do you do that? So let's say I will put a computer count here, computer count, and then what I would do, like a total, you know, maybe the observations here, right? Observations, and then family, right? So number of families, what I meant to say, number of families. So let's calculate it. Let me put a different color. Okay, different color. What do you do, like assuming that like I have 1, 2, 3, 4 computers maximum. 1, 2, 3 and 4 computers. That's the max that you have. So now you are what you're saying, you will see. Uh, you will note down first, see, very simple logic. If I have 1, you put a 1 bar, right? If I have 2, you in the 2's place you have to put 1 bar. So let's say start with 1. I put here 1. This is a one more one, so I put one more bar here. Okay, 2. So I'll done. I put here 2 and 3. So I have to put one mark here 3. 2. Again add one more here. 1. I will add here. Okay, 4. So probably I will add here. 3. I will add here. 2. I will add here. And 1 1. So how many have? I have 1 2 3 4 and 5. I have 5 families having a single computer, and then I have 3 families having 2 computers. I have 2 families having 3 computers. I have 1 family having 4 computers. How much total? 10, 11, right? Total 11, 11 families. So you have 11 observations, and this is how I think you're distributing. This is what we can call it as a discrete series. So you started from the raw data only, but you formulated as a discrete data. So discrete data here means like a frequency of observations are taken into consideration is a key. Are you clear? Good. Next topic is continuous series. Try to understand what is meant by continuous series in the quantitative data. When the data contains a large number of observations, what you have to do is like you have to find a easy way to actually put them together, right? What we do is like we will arrange them in the different groups called a class intervals. So you make like a class intervals and you try to put your data in it. So let's say like 1 to 10, 11 to 20, 21 to 30. These are how I think class intervals that you define. Your observations can be noted down within that. If any number appears between 1 to 10 would becomes like this class. If any number would appears between the 11 to 20, is belongs to either 11 to 20 class, and then similarly so on. Right, this is how I see. Like, so basically what you are saying is like when you have the large number of observations, it's a easy way to put them together and then do the rest of the statistics is a class interval method. So this is what we can call it as a continuous series of data, and then how you interpret the data, how you are you know uh, simplify a data so that you can infer the meaningful data from meaningful information from the data, right? So this way the quantitative data is classified into individual series, discrete series and continuous series. We also see in the examples of each one, and then and this is actually the simple concept but is useful concept. Let's do a small exercise with me. Frequency distribution table. We are constructing the frequency distribution table from the raw data. So since I am seeing like a large data, rather I am doing like an individually, I am just putting them in class interval data. Okay, so between 1 to 10 I have to see like numbers and then put them in that class. Let's start. I have 1, so 1 would be like 1 to 10 class, so I will put like 1 here. Okay, and the 2 should also be in the same class, and then 7 would be where, maybe say in here only. 7 and 9 is also here. Okay, and 15 is second class. 11 to 20 class. 16 would also be here, and 17 would also be here. Agree? And then 18 would also be here, and then 19 and 22, right? Okay, and 22 where, this class. 24 this class. 25 this class. 25 again this class. Again 25, sorry, this class. 27 would also be there, second set. 27, 28 would be in the same class, and 29, 29 where? I think this same place, 29, 32 again move to the next class, 33, right? 35 twice. I have to put 35 twice here. Okay, 37 is also same class. I'll put here. 42 would be this class, right? 43, 44, 43, 44. Okay, 40, and then 45 again here, and then 48, right? 48 also here, and then I have two 50s. So two 50s. Now I counted. So now my frequency would be one within the 1 to 10 class. How many observations that I made? Four observations. Correct, no? So I put a four observations. So 11 to 20, how many have? I have 5 plus 1, 6 observations, right? And then here, this 5, this plus 3, 8 observations. I have 5 observations. How many? 5 plus 2, 7 observations. So this is how my frequency distribution table can be constructed from the given raw data. Let's move on. From the frequency table, there are the four concepts that are to be taken away. So let's say I have the class intervals like this. What is meant by class interval, right? Class interval means, this LHS, lower limit and upper limit, as an interval. So this is what we can call it as a class interval. And a group into which raw data is considered is called a class interval. Okay, what you're saying? A group which raw data is considered. Okay, that's called a class interval. So now the question is, what is meant by boundaries? So we have two boundaries, a lower limit and upper limit, right? Lower limit and upper limit. Those are called boundaries of the class boundaries. So whenever the class boundaries, you have a lower limit, low, lower limit, you have a upper limit, right? So that is why this lower limit, upper limit is nothing but a class boundaries. We have two topics here to discuss, inclusive and the exclusive. Okay, exhaustive form, exclusive form, right? Basically, I think, I'm sorry. Exclusive means like what, and inclusive means what? Exclusive means like you are only considering, let's say, 11, 20, 11, 20 class. That means like when you say exclusive, that means like you are only considering 11 and 20 in between. That's it. That you are not considering anything more. If at all inclusive, then the limit would be like 10.5 to probably you will go with 20.5, something like that. But mostly we will consider the first case only. First case would be your exclusive case. Next thing is like a class size. What is meant by size? Size, width, height, whatever it is. So if you look at 11, 20, 110. So this is what I think you call it as a your you know the size, basically, right? The difference between the true upper limits and true lower limit is called a class size. Okay, the class size, simply you can consider this way: differentiate to lower and to upper, you will get it. That's a class size. So 40 minus 30 equal to 10, or else 31 minus 21, 10. So this is a class size. And then class mark are the mid value. So how are you going to calculate mid value? You know that, right? Average, basically upper limit and lower limit ka average. Have upper limit plus lower limit, right? This is what called as a mark or mid value. So let's say if you take like a 110 case, class 110, how do you calculate a class mark? 1 plus 10 divided by 2, so 5.5, right? So similarly you can calculate rest. So the key terms to take away is what is meant by class interval, what is meant by class boundary, what is meant by class size, what is meant by mid value or class mark. I hope you're clear. Yeah, sure. Thanks for watching. Please like, share, subscribe, click on bell icon and leave the comments. So we are reached at the end of the session. Thank you all who are actually made to this class today. Stay tuned to the next session. Have a good day. Bye bye.